In this recording, we're going to review some of the prerequisite information for our Unit 7 on exponential functions. So hopefully you have your blue card that you can work these out on. First thing I'd like to do is actually start at the bottom with the powers table. So if you could scoot down to the bottom, you're going to need a graphing calculator or some calculator that can do exponents. I guess it doesn't need to be a graphing calculator, some sort of a calculator that can do exponents. And I want you to fill in all in this table. So just to make clear what I'm looking for you to do here, x represents the numbers 1, 2, 3, 4, and 5. Okay, x squared, so it'd be like square those numbers. So it'd be like, that's why the 9 is here, because it's 3 squared. And the cube column, so 3 cubed. Okay, and the fourth column, so 3 to the fourth. In other words, it's going 3 times 3 times 3. Kind of looks like a geometric sequence, doesn't it? Cool. And I want you to fill in all those numbers. Now, x to the 0, okay, that came out to be a 1. And then x to the negative 1, well, that came out to be 1/3, all right? And x to the negative 2 came out to be 1/9. X to the negative 3 came out to be 1/27. As the directions say, use fractions here, not decimals. Okay? So fill in all of that using your calculator, graphing calculator, scientific calculator, and then play the recording when you've got your answer. Okay, so hopefully you took the time to work all those out. Here are the answers. Okay, you got your squares, your cubes, fourth powers. I would say with your fourth powers, kind of the critical stuff, in terms of stuff you'd want to be committing to memory, you'd want to know your first bunch of squares, certainly. I would say the first 5 cubes, and less important to know your fourth powers, but maybe if you knew them, something like this. If you knew that 32 was a perfect fifth power, that would probably be useful to you. Not that you couldn't figure it out from your calculator, but just like it's important to know the squares, it's handy to know the squares. It's handy to know that 16 is a perfect square. It's also handy to know that 27 is a perfect cube and 81 is a perfect fourth power, that kind of stuff. Okay, notice some stuff here. That over on the right, that should be like you knew that already. X to the 0. Notice how all these came out to be 1s. Interesting, because as we divide, as we go to the left, like 32 divided by 2, divided by 2, divided by 2. Well, when you divide 2 by 2, you get a 1. You divide 1 by 2, you get a half. So now we're getting into the fractions. Half, 1/4, 1/8. Notice how these are mirror images of these. Hopefully you made that connection. All of these are reciprocals. So 8, which is x cubed, 1/8, which is x to the negative 3. So it turns out a negative exponent means take that number, that 8, and put it in the denominator. Okay? So it's 1/x cubed. Pretty cool. So I think we just figured some stuff out that's going to help us up above. Notice all the fractions are on the left. Negative exponents make fractions. All right, so now when we get into our exponent rules, we've already figured some stuff out. So x to the a times x to the b, well, that would be an example like this. I'll just have a little scratch space over here. That would be like x squared times x to the fourth. Well, that would be something like x, 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 x. Well, that's 6 factors of x. Just add the exponents. So it's x to the a plus b. Right? The next one, when we divide, that would be more something like this. Clean that space up a little bit. When we divide, the way I think about it, if I had x to the 5th over x squared, I would think of it like this. You can write out all your x's, x, 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 over x, x. Okay? Those divide out, and you're left with 3 factors of x. So the shortcut is subtract 5 minus 2. So x to the a minus b. Right? So dividing is like subtraction of exponents. Multiplying is like adding your exponents. right? The way I typically think about it is, where are there more x factors? Well, there's more up on top. How many more? Well, there's 3. Okay, so if I were to flip that around and make it x squared over x to the 5th, it would be, where are there more x factors? Oh, there's more on the bottom. How many more? 3. So you could write it as x cubed, but it would need to be on the bottom. Or, as we saw, you could write it with a negative exponent, x to the negative 3rd. That would be equivalent, but it's not considered simplest form. You want to have positive exponents in simplest form. Next example. This is a power property. So we've got a exponent raised to an exponent. I can illustrate that for you as well. Feel free to fast forward through this if you already know this stuff, but if you're curious about it and you don't know why, if I have x squared to the 3rd, what that would be is, I've got an XX, a little package of x squareds, but I've got 3 packages of them. So it's like the cube means you have 3 of that factor, and the x squared means that little grouping has 2 x's in it. So of course that's x to the 6th. I multiplied 2 times 3. So it's x to the AB power. All right. Next one, x to the 1. Well, anything to the 1, as we saw before, anything to the 1 is itself, and anything to the 0 is 1. That's an important fact, but we have a little caveat. Okay, so x to the 1 is x to the 0 is 1. However, x cannot equal 0. You can't do 0 to the 0 power. It's not defined. Okay? To the negative exponent, what we discovered before was it means you have a positive exponent as a power in the denominator. Now, flip it around. If you have a negative exponent already in the denominator, what that means is it just comes up to the numerator and becomes a positive power. All right, and finally, if you have a fraction that's raised to an exponent, you just distribute that exponent to the numerator and to the denominator. So it's x to the b over y to the b. All right, so let's have you practice that and apply that to the examples in the middle here, and then play the recording when you've got your answers. Okay, so hopefully you took time to work these out. The rules are no negative exponents or parentheses in simplest form. And I guess the way I would think about it is, first, we're going to deal with any negative exponents. Okay? First, deal with any negative exponents. Next, we're going to make sure we take care of our parentheses outside the exponent, our exponents outside the parentheses. And then finally, we're going to make sure we don't have any multiple factors. We don't have z's in more than one place. Okay? So m to the 0, well, anything to the 0 is 1, so long as m is not equal to 0. All right. This one, x squared times x cubed, should come out. We add those exponents. That should be to the 5th. This one, well, there's 2 ways to think about it. You could subtract the exponents. 4 minus 0 is 4. Another way to think about it, hopefully you recognize this also, that's just a 1 on the bottom. So ignore it, right? Just x to the 4th. This one, we have 7 little packages of x squareds, so we multiply those. That comes out to the 14th. We'll make a better 14 there for you. All right. This one, 2 to the negative x. Well, we said if we have a negative exponent, it becomes positive power in the denominator. So 1 over 2 to the x. With this one, if we have a negative exponent, we said we deal with that. The x squared goes down to the denominator, and it combines with the x to the 4th that's already there. Okay, so 1 over x to the 6th. There's another way to have thought about it. If you just thought about subtraction, negative 2 minus 4 would be negative 6, and then the negative 6 would become a positive 6 exponent in the denominator. Okay? G is a little more complicated, so I'm going to use a little more space. Okay, for G, Okay, let's first, you don't have any parentheses, so let's first deal with those negative exponents. So if it's a positive exponent, I'll leave it where it is. X to the fifth, I'll leave it where it is. This y to the negative third, I'm going to bring down to the denominator, okay, and make it a positive exponent. This x to the negative fourth, I'm going to bring up to the numerator. Okay, so any exponent that is negative, the general technique is bring it to the other side of the fraction and make the exponent positive. And finally, my y to the negative 1 comes up to the numerator and becomes a positive 1. Okay? So I took care of all those negative exponents. Now we just have to simplify a little bit. We shouldn't see x's in more than one places, or y's in more than one place. So I've got a 2 up top, x to the ninth on the bottom, top, and then my y's. Well, there's 3 on the bottom, 1 on the top, so where are there more? 2 extra factors on the bottom. That's our simplest form. So we don't have x's and y's repeated as factors, don't have any negative exponents, don't have any parentheses. Okay, back to the other page. H. All right, for H, so we said our answer here was, if I recall, 2 up on top and a y squared on the bottom and an x to the ninth up on top. All right. Next, we're going to distribute this cube to both of those two factors. Well, negative times negative times negative is a negative, so it's going to be a negative 64, and then just z cubed. All right. And then I and j we're going to work out on our separate paper. So first we're going to deal with that cube. And I'll distribute that cube, so that's 27, which is 3 cubed. You think of it like there's a little 1 for that z exponent. So 27 b to the 15th power z to the third power. You're going to multiply that by another b and another z. Let's put exponents on those. All right, so that looks to me like a 27 b to the 16th power z to the 4th power. All right, and finally, complicated one here. First, we're going to deal with those parentheses. So we're going to distribute the square to all the terms, so it looks like 16, and then x to the 4th. And again, that's not because 2 is being squared, it's because I'm multiplying the exponents. X to the 4th and z to the 4th all over 8x cubed z to the 1st. And I can simplify that by dividing. So 16 divided by 8 is 2. When I deal with my exponents for the x's, there's an extra 1 on top, x to the 1. Don't have to write the 1. And then z's. Well, there's 4x z factors up top, 1 on the bottom. Looks like 3 extras on top. I think we did it. I think we got all those answers in. Thanks for watching.